Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a truly bizarre and brilliant feat of engineering, solving Sudoku puzzles using Tmux. It's not your typical Python script, folks.
Oh, this sounds wild. I've heard of Tmux, the terminal multiplexer, but a Sudoku solver? What's the core idea here?
The author cleverly uses Tmux features like hooks and variable expansion to create a program that iterates through possible solutions. It's not elegant, it's brute force at its finest. He even avoids arrays and strings, relying on Tmux options as variables.
No arrays or strings? That's intense. How does it represent the Sudoku grid then?
Each cell is a Tmux option, like at x2, y0 feet 4. Tedious to set up manually, so he wrote a script to convert a human-readable grid into these Tmux commands. The blank cell's coordinates are stored in another option, a string like 001, 03, 05, 06, 07, 080, 112, 17, 18, 10, 212, 3262, 0333, 5383, 042, 43, 444.
So how does it actually solve the puzzle? It's not using any sophisticated algorithms, right?
Exactly. It's pure brute force. It checks if the grid is solved using a massive variable expansion. Imagine concatenating all rows, columns, and 3x3 blocks into strings, and then checking if each contains all digits 1 to 9. This check is done with Tmux string matching capabilities.
That sounds incredibly inefficient. How does the control flow work? Does it use loops or something?
No loops, surprisingly. It uses Tmux's if command with variable expansion for conditional logic and a recursive send keys trick. It's like a state machine jumping between two key bindings. One checks if solved, the other increments a blank cell and recursively calls itself.
A recursive send keys trick? That sounds like a recipe for disaster. How does it avoid infinite recursion?
Good question. It's carefully designed to avoid that. The recursion is managed by the key bindings and the send keys command, jumping between states. It's incredibly clever, but also incredibly fragile. One wrong keystroke, and you're in for a world of pain.
I see. So how fast is this monstrosity?
Not fast. For a Sudoku with 4 missing numbers, it took 41 seconds. With 5 missing, it took almost 7 minutes. The author estimates that for a typical easy Sudoku, it would take an astronomically long time. It's a testament to how inefficient this approach is, but also how much you can do with Tmux if you're determined enough.
Amazing. It's a fascinating example of pushing the boundaries of what's possible, even if it's not the most practical solution. Thanks for breaking this down for us.
Absolutely. It's a reminder that sometimes the most interesting projects aren't about efficiency, but about exploring the limits of a system. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.